Hi there, my name is June. I'm a poster from Taiwan. Today I'm glad to share my work with you. It's entitled Massively Parallel Multi-Mediator Analysis under a Composite Null. So the problem we're dealing with, considering a single exposure and multiple outcomes, and a mechanism is to describe what may happen from the exposure to each outcome. Each mechanism is formulated using a causal graph with multiple mediators. So what we want is to evaluate all the mechanisms within one experiment. Therefore, we need test statistics for each mechanism, but there are issues for testing the mediation model. Considering a model of a single mediator, the test statistics will be composed by two coefficient estimators to test the null hypothesis that alpha times beta equals to 0. So the first issue is, the test statistics is a normal product. Using normal approximation will give you conservative conclusion. The second issue is, this null hypothesis is a composite null of three simple nulls. If we do not know the proportion of the three nulls, we cannot access the true null distributions. But thanks to Dr. Huang, we already have a solution, that is to use a composite test. In this study, we provide three p-value assessment approach to evaluate the mediation effect. We began with constructing the test statistics A and B for alpha and beta, and the composite test can be constructed by numerical approximation of normal product distribution. For comparison, we also demonstrate the result of joint significant test that choose the bigger p-value and Sobel test that use normal approximation. As our aim is to evaluate all the mechanisms within one experiment by applying the composite test to the multi-mediator model with correlated mediators. In this study, we developed local and global approaches to achieve this aim. In the very beginning, we have to estimate all the coefficients of each mechanism. The local approach applies the composite test first, then obtains the graph level statistics for each mechanism. The global approach, on the other hand, obtains the graph level statistics first, then applies the composite test. Let's go into the details. The local approach includes three steps. Since the composite test requires the independence between A and between B, the first step is to decorrelate mediators. Here we use P to denote the decorrelated mediators. Then we estimate the coefficients and use the composite test to assess their p-values. And finally, we integrate these path-level statistics into graph-level statistics. The input of the integration is the path-level Z statistics within one mechanism, and the output is one graph-level statistics. We provide three graph-level test statistics. Both Berg-Jones and Hierarchism consider the count of significant paths. The Berg-Jones statistics is a likelihood ratio test, and the Hierarchism is a wall test. The minimum p-value uses the strongest path to represent the whole mechanism. Then, as a global approach, there are two steps. The first step is to integrate the path-level statistics into two graph-level statistics. Then apply the composite test to assess the final p-value for each mechanism. Since mediators are correlated, the input of the integration is the rescaled alpha and betas with their covariance matrix. The output are two graph-level statistics corresponding to the alpha and the beta, and we provide 5 graph-level test statistics. The top 3 are similar as above, with more concern of correlation structure. Besides them, we also provide a Hotelling t-squared statistics and a variance component statistics. These are the selected scenarios demonstrating the type 1 error, 5 global statistics and 3 local statistics, with or without decorrelation. We have 30 mediators. In general, the p-values do follow a uniform distribution, except the situation of skipping decorrelation or insufficient sample size. We can also observe that joint significant tests and Sobel tests are being too conservative, and the scenarios demonstrating the power. First, when signals are sparse, composite test performs better, but joint significant test has a better power when signals become dense. Within the composite test, we find local approaches have better power when signals are consistent, and global approach performs better when signals are diverse. Summarizing the simulation results will provide guideline to select proper test statistics. T-squared performs well in general, but it needs sufficient sample size to control type 1 error. Variant component test also performs well, and it can be estimated using limited sample size. Otherwise, local approach can better detect consistent signals, and global approach can better detect diverse signals. Conclusion. We introduced the graphical model to describe experiments with many possible mechanisms from one exposure to several outcomes. We developed two approaches to evaluate the mediation effect. Local approach with 3 test statistics and global approach with 5 test statistics. And we performed numerous simulations to provide a guideline for selecting the best practice. Thanks for watching till the end. Please leave me a message in case you have any questions or comments.